Let us try to solve the differential equation here. It is given that x is equals to 1 when y is equals to 0. To solve this, copy down the function here. Put dy dx on one side while the rest on the other side. This involves rearranging the function here, which eventually give you this. Let y equals to vx. Differentiating y to the x based on the product rule, dy dx will be equals to this. Substitute the y into the function here, whichever have the factors of y, and substitute the dy dx in the equation here. That will give you this. Expand and reorganize the functions. Move the v to the opposite side as a negative v. You will need to merge this v with the fraction here. With that, try to multiply these functions to be divided with it so that you have the same domain. Now merge the functions here. Simplify the functions. Move the x to the opposite side. You will get this. This can later be simplified into this. From the function here, you see there are v and also x as the variables. Separate the variable so that one side constitute the v while the other side constitute x. The function here still looks quite complex, and it is difficult to directly integrate it. As your next step is to integrate the entire expression here, you may use the principles of partial fractions to expand the functions. Factorize the functions here, you will get these two, which based on the principle of partial fractions, you will have this. Try to merge the fractions, you will get this, and compare to the original function here. Solve the two functions simultaneously, you will get a equals to 4 and b equals to -1. With that, integrations of these functions can be rewritten into partial fractions in this manner. This will be easily being integrated. Integrate the entire expressions, you get this. In the function here, you have v and x. You know that v is a component of y equals to vx. If you rewrite this, v will be equals to y per x. Substitute the v in the function here by y per vx, you will get this. It is given that x equals to 1 when y is equals to 0. Substitute the numbers into the equation there. Long 1 will be equals to 0. And this simplifies the solution here. You will obtain c equals to long 2. With that, substitute c equals to long 2 into the equation here, and you obtain this. Based on the law of log, you can move this to become the power of these functions. This is actually the combinations of the two terms here into per x functions. Same goes to this, which is rewrite from the function here. And the plus relationship of the long can be in the form of product for the terms inside. Merge the two functions by multiplying themselves within the long. Now you may remove the long from the both sides, and this will be your solution.